Our knowledge of climate change is still imperfect, but it's a field scientists have been building on for decades. CBC's science correspondent has been following closely since the 1970s.
Hi, I'm Bob McDonald. There's a new element involved, one that we introduced, global warming.
Is there a consensus out there that climate change is real?
And bringing us the stories.
So the Earth is getting warmer.
Now he's here to answer the questions you asked.
Bob, thank you.
My pleasure.
We always appreciate the opportunity to put our questions to you directly. So I was surprised, and I have to say impressed, that you've been looking at the science of climate change for as long as you have.
Just about 40 years, Heather. Yeah. And what's interesting about this is that when I first started back in the 70s, there was a debate in the scientific community about which way the climate was going to go. Because one side was saying, you know, we're overdue for an ice age. We should be going into another ice age. Because you follow the pattern of up and down, the period of warm is about 10,000 years, and it's been 12,000 years since the last ice age. So they're saying it's going to get cold. But then there was another group saying, yeah, but there's this stuff called greenhouse gases that we're putting into the atmosphere and a phenomenon called global warming. So it's going to go the other way. So at the beginning,
both sides had
both
sort
sides
of equal...
were almost equal. And it's been really interesting to see how it's turned out since then. All the predictions of those who said it's going to get warmer have been coming true.
Okay, well, hold on to that thought for just a second, because I want to ask, even from the earliest days, though, when you were beginning to investigate this science, did you have a sense that climate change or something related to warming or the climate was going to be the pressing issue of our day?
Well, I knew that it was going to be a big issue, because that was a time, you know, in the 70s when Earth Day was around and the Environmental and Protection Agency. Rachel Carson had put out Silent Spring. We got the pictures from the moon of the whole Earth, the big blue marble. So we were really looking inwards on the Earth as a whole and realizing, hey, things are changing and we're causing them. And we got to start looking at this, not just climate change, but pollution, food, oceans, extinctions, all kinds of stuff.
Where are we now? Because here we have a brand new U.S. ambassador to Canada, who just the other day, Kelly Craft, said she believes both sides of the science of climate change. And one of our viewers, as we begin with the first of your questions, Albert Couillard, said, are there two sides today? What are both sides?
Well, the perception of both sides is in the public mind. And that's where there appears to be a debate about whether or not it's really happening. In the scientific community, there is no debate.
It's clear.
Clear. On the public side, there's been a very well-organized and well-funded campaign that we now know was funded by an oil company to put doubt in the public mind by saying, well, you know, maybe not, maybe not. On the scientific side, the United Nations went to the scientific community in 1988, and they asked the same question. Is climate change real? Are humans affecting it? And they gathered together the Intergovernmental Panel on Climate Change, the IPCC. They gathered 1,300 scientists from 50 countries, representing every climate part of the Earth, the entire Earth. And they asked them not to do original research. They said, why don't you gather all the research you can find that's already been published, that's already been through the scientific rigor. Gather it all together and tell us what you see. So they did that. Then they gathered this stuff together, they put that out for scientific review, and then they put out a report. And the majority, the overwhelming majority of all of them said, yes, it's true, it's going up, and humans are responsible for some of it. Now, where the debate within science is, what happens now? So you got the optimists that are saying, well, you know, if we do something, it'll only go up this much. And the pessimists saying, we don't do something, boy, it's going to get really bad. But generally, the trend is still up.
Why is what is happening now different from what has happened past?
And that's an excellent question, because the Earth has gone through dramatic changes in the past. When the dinosaurs were here, the Earth was warmer than it is now. And we've had 5 ice ages. So the Earth has gotten cold and warm and cold and warm, and now we're in a warm period. So yes, the Earth's been getting warm for the last 12,000 years. What's the difference? The difference is that in addition to all those cycles that the Earth naturally goes through, long ones that take thousands of years, short ones that only take decades or even just years, the human aspect, what the scientists are seeing, is on top of that. That stuff is the background. That's always been there. What we're seeing is on top of that, there's this acceleration. And it's the rate of change that the scientists are concerned about. We are doing within decades what used to take thousands of years to do. So the changes in the past were very, very slow. So now we're pushing it. We have our foot on the accelerator, and we're causing changes that are happening very, very quickly. And this is a problem because nature doesn't have time to adapt to that.
We had just this week from the United Nations, I mean, what I interpret as a pretty dire warning, that the concentration of carbon dioxide in the atmosphere, I want to make sure I get this correct, increased at record speed last year. It's now reached a level not seen for more than 3 million years.
That's correct. And this change that we're seeing now that hasn't been this way in 3 million years has all happened within the last 150 years, since the beginning of the Industrial Revolution. You see it on the charts. You see when that curve starts to accelerate up, it all happens when we began burning coal, oil, and natural gas. So it fits. So the solution is obvious. You know, we got to stop putting the emissions in. But even if we stop today, it would still continue up for a while before it would peter off.
Okay, even if we stop today. Victor from Vancouver has a question about that very point. Hasn't humanity passed the point of no return regarding carbon dioxide emissions? Of course, he says, I'm against carbon pollution. But is there still time to make a difference?
Yeah, that's a hard question to answer. There have been a couple of milestones that the scientists have put out. One of them is 400 parts per million of carbon in the atmosphere. We're already past that. We passed that last year. We may never go below that. And the other one is the 2-degree rise. And they're saying if we don't go beyond 400 and if we don't go beyond 2 degrees, the warming would level out. And over a long period of time, it would level out, and then maybe it would start to come back down again. But that means stopping all of the industry that we have now, today. And that's not going to happen. So that means that we're going to go up a little higher than 2 degrees. We may even go up to 4 degrees. And just as a context here, going up 4 degrees, the difference in average temperature between the Ice Age and today was 5 degrees. 5 degrees. When you talk climate, people say, gee, that's not much. What's 2 degrees? God, it goes more than that between yesterday and today, between day and night, between winter and summer. What the heck's 2 degrees? And that's the difference between weather and climate. Weather is what happens every day. Climate is an average. It's
okay, wait, that's Tom. Okay. Tom Wilson wanted to know. Tom is reading our mind because Tom wants to know the difference between climate and weather and how one affects the other.
Right.
So he's speaking exactly to this. What's measly 2 degrees?
I love the way these all flow into each other. So weather is what happens every day. It's what you see when you look out the window. Weather is what you see. Climate is what you get. Climate is what's going to happen because climate is an average of the whole Earth over a long period of time. So you say, okay, what's the average temperature? It's like average sea rise as well. They talk about the sea level going up inches. So, gee, the tide's more than that. So it's an average over a long period of time. And to move the average temperature of the Earth up takes a lot of weather. It takes a lot of storms and circulating the air around and shifting climate zones and shifting the water, even shifting the continents. And so that's why a little bit of change in the climate means a lot of change in the weather.
A number of viewers, Bob, are wondering about methane, specifically the warming Arctic and the fact that that is accelerating global warming because of the methane being released in the Arctic. So explain where that gas comes from and the effect that it has.
This is a ticking time bomb that really worries me a lot. Methane is another greenhouse gas, and it has the same effect on the atmosphere that carbon dioxide does, but it's 20 times more potent. So
because it absorbs more of the sun's energy, correct?
That's right.
Okay, so it makes it a more.
Yeah,
okay.
That's right. So it's a really, really potent gas. And there is more methane in the Arctic ice right now in permafrost. This is underground, not glaciers, it's underground. There's more methane there than there is currently carbon in the atmosphere today that's stored. Now, the reason you get methane out of the Arctic is because mixed in with the ice are all the dead animals from the last time it was warm up there. The mastodons, the woolly mammoths, the short-faced bear, the giant sloths, camels, and
they're
grass,
all there.
They're all in there. Right? That's organic matter that's been frozen. So when the ice melts, that stuff rots. That's where you get the methane. It's from rotting organic matter. So that will add to what we're already talking about with all the human carbon emissions. And unfortunately in the Arctic, it's accelerating. The Arctic is warming faster than the rest of the world because it's an ocean covered in ice. And ice reflects sunlight back out into space, so it stays cool because it's white. When the ice melts, you get dark seawater. Seawater absorbs heat, absorbs sunlight and gets warm. So that's why the Arctic's getting warmer, and then that causes the permafrost to melt, releases the methane. So it's called a feedback loop. So I worry about that one a lot.
Well, so does Howard Eakins, who asks something building on this. If the Arctic ice is receding, is it possible that ocean currents could change? And could those currents carry colder water and the associated weather to regions south?
Yeah, this is a concern that's been around for a while. The ocean currents, they're like liquid weather. The middle of the Earth is warm because that's where the sun is. So the equator is warm, and the top and the bottom of the Earth are cold. Heat likes to go towards cold. So the warm water from the tropics wants to go north and south. So we have the Gulf Stream that comes up the east coast of North America. And it's bringing warm water up to the north. When it gets to the north, cold Arctic water sinks, it's heavier, it sinks, and it flows along the bottom of the ocean back south again. So there's this big conveyor belt of heat and cold moving between the north and the south. But you need a difference in temperature to do that. If the Arctic gets warm, then there isn't as much draw, and they're worried that the Gulf Stream will cut off. So it could disrupt the ocean currents. The ocean currents really drive the weather a lot. And that's why they call it climate change rather than just global warming.
All right, here's another question, a great one from Catherine. We've talked about ocean water, salt water. Canada, of course, a land of lakes and rivers. So what are the projected impacts of climate change on the freshwater ecosystems of our country?
Canada has more water than anyone. We have about 20% of the world's fresh water is in Canada. It's astounding. So in some areas, as the temperature goes up and we get more droughts and the glaciers melt, rivers are going to dry up. So there's a good chance that in the west, because the glaciers feed rivers like the South Saskatchewan and things like that, they will be getting less water. In terms of the Great Lakes, which is where most of our industry is and where a good part of our population is,
30 million Canadians and Americans in that basin.
it can go either way. It can go either way. The area is predicted to get warmer, so if you have hotter summers, that means more evaporation. So the lakes lose water just from the heat. And if you have shorter winters, that means less snowfall. So in the spring runoff, there isn't as much snow melt to recharge them again. So that means they could go down. On the other hand, it could go in the opposite direction because if the storms, the hurricanes that are coming across the Atlantic Ocean and hitting the United States, especially the ones that come into Texas, like we saw this year, those storms are getting stronger, which was also predicted. If they get stronger, that means they'll come up the land into Canada and bring more rain into the Great Lakes area. And also, we have to think about water in terms of the free trade agreement with the United States.
For sure.
Because the U.S. has plans to drain the lakes to feed the hungry Southwest, because they're going to be really feeling droughts down in the desert regions. And can we allow them to do that? How do we deal with that? So the Great Lakes are a jewel. They're the largest freshwater system on the planet. And we really have to take care of them.
Nancy Mead must have been watching the last time the two of us were talking. And Nancy has a question about space. Do you think that missiles, space travel, have any effect on climate?
Well, rockets spend about 2 minutes in the atmosphere when they take off. After that, they're above the atmosphere. So they're not like high-flying airplanes that are putting carbon dioxide out for hours at a time. So no, they don't affect the climate that way. On the other hand, if it wasn't for spacecraft, if it wasn't for those rockets to put satellites up, we wouldn't even know about most of our climate issues. It's thanks to satellites that we spotted the ozone hole over Antarctica. It's thanks to satellites that we get our weather every night. I mean, in your business, right, you always go to the satellite weather. It's satellites that are showing us the shifting ocean currents, El Nino sloshing back and forth across the Pacific, these decadal oscillations that happen in the Arctic. We didn't even know they existed before we had satellites. So I think we should be thanking the space program for our environmental awareness rather than be worried about its effect on the atmosphere.
Okay, maybe not so much aviation, because that has a disproportionate effect, doesn't it? And people are trying to figure out cleaner ways to fly around this world. Lindsay Foti, how is climate change affecting our bodies, the human body, Bob?
The human body is one of the most remarkable adaptations in evolutionary history. One of the reasons Homo sapiens survived is because we are adaptable. We can adapt to climate change. And actually, it was partly climate change that made Neanderthals go extinct 100,000 years ago. They couldn't deal with it. We did. So we're really good at adapting. So I'm not worried about the human body. However, we are causing, not just through climate change, but through habitat destruction and our food and our population, there's 7 billion of us, we are causing the greatest extinction since the extinction of the dinosaurs. That's the scale of extinction. The animals are going extinct at the same rate as the last time a big asteroid hit the Earth. That's serious. So will it affect our bodies? Yeah, I'd like to eat. You know, what about food? What about the fish in the sea? We're affecting insects that are coming north and killing off our crops. We're having to adapt to that because of insecticide resistance. We have diseases coming up. We got antibiotic resistance. We're trying to fight that. So we're being affected indirectly, not directly by the climate change itself. It's all those other things we're doing. We're at the top of the food chain. And if we knock out the bottom of the food chain, we're going to go with it. And the bottom of the food chain is being affected right now in a very serious way.
Great question, Lindsay. Thank you very much. Getting to very close to the end. My goodness, we could have. Yeah. There's a lot of science to cover. This is we alluded to this, but I think it's probably worth mentioning. Dave Lycan has a question about whether climate change is affecting the whole planet equally.
That's a great question. I like that one because the Earth is not being affected in the same way in all locations. Some areas are going to be experiencing more droughts than other areas. Island countries are feeling sea level rise. The ocean's rising for two reasons. As it gets warmer, which it is, it expands. Anything that gets hot gets bigger. So the ocean's actually inflating itself just by getting warm. Plus, we're seeing all this melting of Antarctica and Greenland. The ice that's on the land is flowing into the sea and rising it up. And they're predicting a meter, maybe 2 meters of rise in the next 100 years. That's a lot. Again, on an average. That's an average. So that means storm surges will be blowing in. We saw New York City destroy part of it inundated a few years ago when a storm came up the coast. We'll have floodings. Florida's going to start feeling it more because it's so low. They're going to feel the sea level rise and the warming down there. And the Arctic is warming quicker than anywhere else on the planet. So yes, it's not even. It's not even. And there are even some areas, like the middle of Antarctica, believe it or not, is actually some years getting colder because there's a polar vortex there and the air actually goes down in the middle and it causes a cooling region. Some deniers say that. You know, the Antarctica is getting colder, not warmer, but it's only in one spot. So it's very, very complicated. And that's why we have to keep watching it. It's not an easy picture. It's not an easy picture. And even the way that the temperature goes up, it doesn't go up evenly. It'll go up sometimes, then it'll level off for a bit. And everybody says, hey, look, it's not warming, it's not warming, it's not warming. Then it goes up again. And then it levels off and it goes up again. So it's a complicated picture. The Earth has its cycles that it's going through. We have our cycles that we're going through. We can't stop what the Earth is doing, but we can control what we're doing and take our foot off that accelerator pedal to give the Earth a chance. The Earth can heal itself if we stop pushing it. And I really believe we can if we take it seriously and stop saying that there's a debate about this. There is no debate. It's real. Let's just get off the pot and do something about it.
That would be a really great closing comment, except I want you to pick up on it. What can we do both as a country and as individuals?
What I'm finding is that the real change for the future to go to clean energy, to have clean, is happening at a community level. It's happening at the grassroots level. It's not happening at the federal level. It takes a long time for big governments to change their minds. And then you get a new government that comes in anyway. But I'm finding that individual towns, communities, and even provinces and states are taking it upon themselves to do this. And they'll do things like, let's have a river cleanup day or a shoreline cleanup day. Let's plant trees. Let's put in more bike lanes in our downtown communities. Let's go back to a village lifestyle where you can walk to things rather than just drive everywhere. And from a politician's point of view, give tax breaks to businesses that are green already so that their price will come down and be competitive. And then educate the public to say, hey, this is a good idea. You know, solar panels aren't as expensive as they used to be. And make your house more efficient when you're renovating it. Put in good, low flush toilets and put in a high efficiency furnace and try to reduce our footprint because efficiency can take us so far. We're wasting so much right now. We could go so far just by making things more efficient.
Clean technologies as a global industry is already worth $1 trillion.
Yeah, and it's growing faster than the oil industry is, yes. There is hope, Heather.
There is hope? Is that what shall we leave it at? There is hope?
I like to believe that. I like to believe that. I think humans are adaptable, we're smart, and Canada has great intellectual capital. And we have the resources and the research community here that can look into building better batteries for cars and better windmills and better alternative clean energies and how to live in a clean way. It's not a matter of going back to the caves. It's not even a matter of losing jobs. It's moving forward. It's evolving. It's just evolving into the next stage of our technology and the way we're going to live. I believe we can do it.
Thanks for helping us learn about this science for these many decades and tonight. Thank you for your fantastic questions. Always great to
Always
speak
great,
with
Heather.
you.
Thank
Thanks,
you.
Bob.